Okay, we're doing chapter 5, test out of the book for the test review. Number 1 says to find the greatest common factor. Okay, the greatest common factor of 28.
Did we turn off the light or no?
Oh yeah, would you please? 28x to the third power.
What page are you?
Chapter 5, test
469.
469.
Okay.
Okay, we're finding the greatest common factor of 28x to the third power and 48x to the seventh power. Okay, the 28 and 48. Okay, what we want to do is find the greatest common factor of those two numbers. So if we prime factor them, 28 divided by 2 is 14, divided by 2 is 7. So 28 is 2 times 2 times 7. The 48 divided by 2 is 24, divided by 2 is 12, divided by 2 is 6, divided by 2 is 3. So we have 1, 2, 3, 4 2's and 1, 3. The greatest common factor would be 2 2's, which is 2 times 2, and they don't both have a 7. They don't both have a 3, so we don't use either one of those factors. So 4 is our greatest common factor of the two numbers. So the 28 and 48, we have 4. And of the x3 and x to the 7th power, they both have at least 3 x's. See, x to the 3rd power is x times x times x. X to the 7th power is 1, 2, 3, 4, 5, 6, 7, right? They have 3 of them in common. So our greatest common factor, I wish I could just do it up a little bit, is the 4 and then x to the 3rd power. That will divide into both of those terms.
That's still part of the first total? The 4x?
Yeah, this is the answer right here. See, the 28 and the 48 had a greatest common factor of 4. And that's what we did. We prime factored it so that we could break it down and see what all the factors are. If it's a very big number, you do this stuff. If it's just something you could look at, like you see the numbers 36 and 8. Okay, they both will divide by 2, but they'll both divide by 4, right? 32 will go into 8 will go into 32, right? So it would just be 8. If you can just look at it and see, you don't have to do all of this prime factoring to find the greatest common factor. For the exponent, take the smallest of your variable.
Okay.
Yeah. So if you had one that said, let's say 9x squared, y to the 3rd power, and 12. X to the 4th and y to the 7th. The 9 and 12, 9 won't go into 12, but they both divide by 3. So that greatest common factor would be 3, and the x and the y, take the smallest one. Squared into the 4, the 2 is the smallest. 3 and 7, the y would be 3. Okay? Yeah. Okay, number 2 wants you to factor completely. Says x squared minus 7x plus 10. Okay. First of all, the 10, you're going to find all the ways to get 10 would be 1 times 10 or 2 times 5. You want the ones that add to give you a 7. So that would be 2 times 5. And you need a negative 7. So it needs to be -2 and -5. So your factors of this, the x squared would be x times x, and the 10 would be 2 times 5. And they both have the minus because they're negative. Okay, the next one, x squared plus 25 minus 10x. What do we need to do before we start factoring? Does that look like it's in the right form to start factoring? So we have x squared and we have our last term as x. We need to put this one as our middle term. So we'll make it x squared minus 10x and then plus 25. Okay, now it's ready to work with. 25 can be 1 times 25 or 5 times 5. Which one do we want? Needs to add to give you 10. Okay, positive or negative? You need a -10. So you need -5, -5. The x squared is x times x, and we'll put the 5's here. That would be -5, -5. You could also write that as x minus 5 to the second power, because they're exactly the same. Okay, number 4. We have 6y squared minus 8 y to the third power plus 4 y to the fourth power. Okay, can we factor anything out before we start doing the numbers over here? Does it have anything in common? 2 and y squared. They all have at least 2 y's in them. Our first term will be 2 times 3 is 6, so 3. Do we need a y? No, and we put a minus because there's a -8 there. So minus 2 times 4 is our 8. Do we need a y? Just 1, right? Okay, and then we put a plus. 2 times 2, right, and then we need a y squared. Okay, this problem you can, is that hard to see? You can reorder this where the y squared is in the front, but you don't have to. Would you rather it be that way? Be easier, wouldn't it? It's more like what we're used to seeing. Let's go ahead and reorder it. Put the 2y squared first, and then the y term, minus 4y, and then our positive 3 at the end. We know the only way to get 3 is 3 times 1. So we already know that this will be a 1 and 3. And the only way to get 2y is 2 and 1. But we need to figure out how to get our 4 here. Okay? If you have the 1 and the 3, and you have 1 times 2 or 2 times 1. Okay, this one right here is a 6. I'm sorry. It wouldn't do that. Let me erase that. You don't do it right there. You do the first times first is 2. 3 times 1 is 3. That does not add to give us our 4. So that's not the one. So this one, you do the first times the first is 1. 3 times 2? 6. That doesn't add to give us a 4 either. So I guess we were done when we factored the 2y squared out, right?
Also the next
This
one.
part is prime. You cannot get it to where you get the 4 in the middle.
So that would be your answer?
Uh-huh. That's as far as you can go.